Okay, so in the next video I want to go over more examples of doing indefinite integrals using U-substitution.
Okay.
Quiet, okay, Robin? Okay. So in this problem, we've got a rational function right here, okay? X plus 1 over x minus 1. And with rational functions, there's not much in the way of algebraic manipulation you can do to put this into like a polynomial that we could, or a power function that we could use as our other methods on. So what we could do is a substitution. Now it's not clear at all what the substitution should be because we don't really have like a composition of functions with an inner function. In this example, we're going to use substitution in a slightly different way to sort of basically as a way of doing a change of variable that will allow us to simplify this algebraically in a way that we previously were not able to do. So here's the trick. Let u equal the denominator. In this example, it's x minus 1. Okay, in this case, that's a linear denominator and the slope is 1, so du is just going to be equal to 1 dx. So the du and the dx are, I can just swap the dx with the du and that'll be nice and easy. Okay, so my denominator is going to become u, but my numerator, so far I'd have a denominator of u and I'm going to have a du at the end. My numerator of x plus 1 is a problem. I can't just put x plus 1 up there because I need to complete the change of variables. I've got to get everything in terms of u. So what I can do is take this u equals x minus 1 and solve it for x. X would be u plus 1, right? Adding the 1 to both sides. And then I can replace the x with u plus 1. So this is like a third substitution we're doing in here. We're taking the variable substitution, kind of flipping it around and replacing the x with a function of u. And that gives me u plus 1 plus 1. So now I've got it so my denominator, instead of having two terms, my denominator only has one term. And that is the key to solving this problem. I now have u plus 2 over u du. And now I can distribute the division by u and get u over u plus 2 over u. And that is the integral of 1 plus 2 over u. Okay, so now let's solve that one. We've got the integral of 1 du plus 2 times the integral of 1 over u du. And the integral of 1 is going to be just u. But the integral of 1 over u, you may remember, this is the natural log of u, right? Because the derivative of the natural log gives us 1 over u. It's actually the natural log of the absolute value of u, so that negative u values are allowed. So it's 2 times the natural log of the absolute value of u, with a plus c on the end. So there's our antiderivative after the change of variables, but now let's undo that change of variables. We'll stick x minus 1 back in, and so we get x minus 1 plus 2 times the natural log of the absolute value of x minus 1 plus constant. And there's our antiderivative. So using U-substitution here, the key was getting it so the denominator, instead of being x minus 1, is just equal to u, so that we can then distribute the division by that denominator and simplify and turn this into a sum of power functions. One of them we use the anti-power rule, so to get from 1, raise that power up from 0 to 1 and get u. And then for the other one happened to be 1 over u, whose antiderivative is a natural log. So anyway, that's another strategy that uses U-substitution.